We are on AP Review, FRQ Topic 6, and I call these miscellaneous problems. Sometimes when there is a combination problem, I put that type in this worksheet packet as well. But most of these that I come across when looking at past AP exams is like they give you a function and then you're asked to answer questions about that function. So that's most of these, but every once in a while, like I said, I'll get a problem that I don't quite know where to put it in our topics, so I throw it in miscellaneous. It's hard to prepare for these because they can ask a lot of questions about these functions. One thing that I do want to quickly review before we get to the examples, though, is how to handle if they give you something with absolute values. We haven't done just a whole lot with absolute values, but this is something that you can do when you come across one when they give you a function with absolute values. So if they do give you an absolute value for a function, and then they ask you things about it, like the derivative or whatever, what you should do is you should change this to a piecewise function. So f of x is the absolute value of x means that f is either x or negative x. If x is positive or 0, then f of x is just x, right? So if x is greater than or equal to 0, then f of x is just x. So absolute value of 3 is 3. Absolute value of 5 is 5. Now the absolute value of a negative 3 is a positive 3, right? So if you have f of negative 3, we need the negative of negative 3, which is positive 3. So f of x is equal to negative x if x is less than 0. And from here, you can answer questions about that. So, for example, if they give you f of x is 3 times the absolute value of x, then I would come over to the side immediately, and I'd say, okay, so that means f of x is 3x if x is greater than or equal to 0, and negative 3x if x is less than 0. And then I can answer questions about it. Maybe f prime. Then f prime would be 3 if x is greater than or equal to 0, negative 3 if x is less than 0. Things like that. So we can answer questions about that. Okay? So just a little bit of a quick how to handle an absolute value function, just in case you come across that. Okay, now let's go and take a look at your worksheet packet. I'm going to do 3 of these with you, like I always do. We're going to start with the problem from 2017. This was number 5, no calculator. Some of these questions, I can see them asking you even if it was with a calculator. Some of them would not be as applicable. It would make it way too easy if it was with a calculator. Okay, let's take a look at this. So for part A, find the slope of the line tangent to the graph of f at x equals 3. Well, slope of the line tangent to the graph of f is f prime. So they're asking us to find f prime at 3. So we first find f prime of x. There's f of x. To find f prime, you can either use the quotient rule or you can pull the denominator to the numerator and give it a -1 exponent. Either way is fine. If you use the quotient rule, many of you like to use the quotient rule, so if you use the quotient rule, just remember that when you start up at the top and take the derivative of 3 is 0. So that first term in the quotient rule is 0. And then you'll have minus the derivative of the bottom times the top, right? So I'm going to write the top first. The derivative of the bottom is 4x minus 7. And then for the quotient rule, you have the denominator squared. So that is f prime of x, and then f prime of 3, we will put 3 in for x. I have 12 minus 7 over 2 times 9 minus 7 times 3 plus 5 squared. So that would be the safe stop answer, and that is the slope of the line tangent to f at x equals 3. The way they scored this back in 2017, it was worth 2 points for f prime of 3. I'm not sure if they split that up. They may have split it up into 1 for f prime of x and 1 for f prime of 3, or they may have just said, okay, it's all or nothing, 2 points or no points. I'm not sure how they did that. Okay, for part B, find the x-coordinate of each critical point of f. So critical point of f is when f prime is 0 or undefined. Don't forget the undefined part, because we have a denominator here for f, so we're going to have a denominator in f prime, right? We do have a denominator in f prime. So don't forget that part. In the interval from 1 to 2.5. So we want the critical points in that interval. And then we're going to classify each critical point as a relative min, max, or neither. So first of all, I want to start off by stating what I know a critical point is, because AP might be given a point for that. We just don't know. When you're taking the test, you don't know what they're going to be giving a point for and not. So be sure to write down information to communicate you know what's going on. So a critical point means f prime is 0 or f prime is undefined. Okay, here's our f prime. We found it above, right? We found it up here. Negative 3 times 4x minus 7 and over 2x squared minus 7x plus 5 squared. Okay, so this f prime is undefined when the denominator is 0, right? So I'm going to go off to the side and find out what x values make the denominator 0. So I'll say f prime undefined when, let's factor that. We have 2x and x, 5 and 1, minus and minus. So x is equal to 5 halves and x is equal to 1. So those are critical points, but I'm looking up here and 5 halves is equal to 2.5 and 1 is equal to 1. So these two values are not in this interval. So we don't have to list those because we only want in that interval. So now back to our f prime, I'm going to set this equal to 0, multiply both sides by that denominator and it just goes away. And the value of x that makes f prime 0 is 7/4. And 7/4 is in that interval. So I will state my answer. F has a critical point of x is equal to 7/4 in that interval. Now to classify, I'm going to put that 7/4 on a number line in between 1 and 2.5, since that's where they told me to look. And I'm going to look for f prime. I'm going to do a sign chart for f prime here. I want to see positive to negative, negative to positive, or maybe no sign change. All right. So if I put something over here, like maybe 1.5, maybe 1.5. So if I put 1.5 in here, this is going to be this is going to be positive on the bottom. So, and this one here will be, this will be smaller, so this will be a negative times a negative, so we have a positive on that side, negative times a negative, positive. And on this side, it's going to change signs, of course, around there, so that will be a negative. So f prime goes from positive to negative, therefore f has a relative max at x equals 7/4 since f prime goes from positive to negative there. And that's the first derivative test. You don't have to call it the first derivative test, but that's what that is. The way this was scored back in 2017, they gave 1 point for that x coordinate, the 7/4, and they gave 1 point for saying it's a relative max with justification. So 2 points for that part of the problem. All right, on to part C. Using the identity that the f of x is equal to this difference of fractions, evaluate the integral, or show that the integral diverges. Okay, so first of all, they were very kind here because they gave us the partial fraction decomposition. Essentially, usually to find this integral, we would have to go off to the side and break it into its partial fractions, right? They did that for us here. So we're going to evaluate this integral using this for f of x. So I'm going to go ahead and do that. We have infinity, 5 to infinity, so it's an improper integral of 2 over 2x minus 5 minus 1 over x minus 1 dx. Okay, first of all, for the antiderivatives. So the antiderivative of this, I have 2 that's on top, 2x minus 5. This is going to be a natural log, but we're going to have to undo that derivative. The derivative of the bottom is 2, so I need to multiply by 1/2. So I have 2 from the top. I'm leaving a space here because of that improper integral. I'm going to write this as a limit in just a second. So 2 times 1/2 ln of the bottom, right? It's a linear term on the bottom. The derivative is 2, so we undo that 2 there. Okay? Minus the derivative of the bottom is just 1 in this case, so it's just natural log absolute value of the bottom. And we're evaluating that. We want to evaluate it from 5 to infinity. 5 is fine, not a problem, but do not write infinity as this upper boundary. You can't have, your boundaries always need to be real numbers, and infinity is not a real number. So do not put infinity up there. Instead, I'm going to call it b for the upper boundary, and we're going to let b go to infinity. So don't forget that's how they want you to. That's how I wanted you to. So we will do that to get full credit here. Okay? All right. So now we're going to begin with, of course, this 2 times 1/2 is going to cancel out, so we don't need to worry about that. We're going to begin with this. Well, before I start plugging in values, let me simplify these limits here. Because if I just begin right now and if I just went and plugged in b and let b go to infinity, I would have natural log of a value going to infinity, which is going to infinity, minus natural log. This is also going to infinity, so we would have infinity minus infinity, and that is indeterminate, so we can't do anything with that. So because of that, I'm going to combine my logs. So the 2's will reduce, and I have natural log of this argument minus natural log of that argument. So that will be natural log of 2x minus 5 divided by x minus 1. Okay? And now let's try putting in b for x and letting b go to infinity. So if we do that, if we put b in for x and let b go to infinity, then the negative 5 and the negative 1 are irrelevant. We're left with just the 2x over x. The x's will reduce out, and we have 2 left. So this will be natural log of 2. And now we're going to put minus, now we're going to put 5 in for x. And when we put 5 in for x, we're just going to get a little natural log. So we'll have natural log of 10 minus 5 is 5, 5 minus 1 is 4. So we have that, and that is the value of that improper integral. So I can see them having something like this on your test, definitely. Even with a calculator would not do you any good here. So I can see them having something like that. The way this one was scored, this was worth a total of 3 points. 1 point for the antiderivative. That would be this step. That's the antiderivative. 1 point for the limit expression. So had to put that limit there. And then 1 point for the answer. Okay, next step. Determine whether the series of f of n converges or diverges. State the conditions of the test used for determining convergence or divergence. Okay? Now notice that this series is going from 5 to infinity, right? The series is going from 5 to infinity. We just now found that the integral going from 5 to infinity of f of x converged. We just found that the integral converged. And now they're asking, does the series converge? So to me, the obvious test would be the integral test, because we just did all of the work for the integral test. All we need to do is to state the conditions for the integral test, and then we can use it, right? So I am going to show you 2 different answers here. One would be using the integral test, and one would be another one that you might do, okay? So 2 possible answers here. Both correct, both fine. What I would do though is I would say, okay, I would say that 3 over 2x squared minus 5x plus 5 is positive, continuous, and decreasing. Those are our 3 necessities to use the integral test for x greater than 5, greater than or equal to 5. Okay? And if you don't believe that, you can put in 5 and make sure that this is positive, but it's going to be true. Okay? All right, so I have to say that. And then I can say that the integral of this converges to what we found it converges to in part C, as shown in part C. Therefore, by integral test the series must also converge. Okay, so that will work. The other way that we could have done this, and if we had not just done the integral, if we had not just found the integral in part C, if they just asked me if this converged or diverged, what I would see is I would see a little comparison test, a limit comparison test, because this series behaves like 1 over n squared. And I know 1 over n squared is a converging p-series. So if we could definitely do this as a limit comparison test. So I would say compare with the series 1 over n squared. Okay? Now, we need to state the conditions for the limit comparison test. And so I need to come off to the side and say 1 over n squared is greater than or equal to 0 for n greater than or equal to 5, which is what we need. And 1 over, well, I would say 3 over, I'm going to say that this is also greater than or equal to 0. For n greater than or equal to 5. Okay, so we need to say that for the limit comparison test. And then we can show the limit comparison test. So the limit as n goes to infinity of 3 over, so I'm sorry, this here. So 3 over 2n squared minus 7n plus 5. And I'm dividing by 1 over n squared. That means I'm multiplying by n squared over 1. That limit is equal to 3 halves, right? It's equal to 3 halves as n goes to infinity, which is finite and positive. Positive. Therefore, our series does the same thing that this series does, right? And I never said what this series did. I would have to come up and say that, and now I need to squeeze it in here. But this is a converging p-series. It's a converging p-series. So this thing converges by limit comparison test. Okay. All right. How did they score this? They gave it 2 points for answer with conditions. All right. Next up, let's see what I picked out next. Next, I picked out number 6, the problem from 2016 to do. So let's take a look at the problem from 2016. Can pull that up. So this was one that's not necessarily like, here's a function, do something with it. This is more of a combination problem that I just didn't really know where to put it. It has some related rates, it has some volume, it has an average value, so it's like a little bit of everything here. So let's take a look at it. All right. The inside, again, this is a no calculator one, the inside of a funnel of height 10 inches. So they are giving us the height of this whole funnel is 10 inches. Has circular cross sections, so each cross section is a circle. Okay. At height h, the radius of the funnel is given by this. So they're giving us a way to find the radius. Okay. Where h is between 0 and 10, because that's the height. All right, the units R and H are in inches. Part A, find the average value of the radius of the funnel. So they're asking us, do we know the formula for average value of a function? And hopefully we do. So the average value, I'm going to call that R sub average from 0 to 10. Okay, the average value of R is going to be 1 over 10 minus 0, b minus a, times the integral from a to b, so 0 to 10, of what you are finding the average of. And we're finding the average of R. So 1/20th times 3 plus h squared dh. Okay, so there's the setup for it. Now we're going to actually find it. So we have to evaluate this definite integral. So I'm going to have 1/10. All right, I think I'm going to take a second here and yeah, I'm going to go ahead and distribute. So this will be 3 over 20 plus 1/20th h squared dh. Okay. You know, I probably should have just taken out that 1 over 20, but that's okay. I'll just leave it in there. Yeah, I'm thinking I should have taken out that 1 over 20. That's okay though. Okay, so 1/10. The antiderivative of 3 over 20 is 3 over 20h. And then this antiderivative, it'll be h cubed, and then we're dividing by 3, so 1 over 60. And we're going to evaluate that from 0 to 10. Okay? So let's put 10 in first. And we have, if we have 10 in there, 10 and 20 will reduce, well, we don't have to reduce anything, right? We can just put, yeah, we can just make it a safe stop situation. Yeah? Minus, when we put 0 in for h, there's an h in both of those, so that will just be 0. And that would be a safe stop spot. Okay, so unless we need that later, I'm just going to leave it like that. Here's how they scored that. They gave 1 point for the integral. They gave 1 point for the antiderivative. And they gave 1 point for the answer. So 1 point for the setup for the integral, 1 point for the antiderivative, that's this part, and then 1 point for the answer. Okay, next up we're going to find the volume of the funnel. Find the volume of the funnel. Okay, well the volume of the funnel. Okay, so volume of the entire funnel. We know that R, we know an equation to find R up here, right? And R all along here. So it would be nice if we could start down here when h is 0 and add up all of the areas of all of the circles, right? That's exactly what we're going to do in an integral. So remember your very, very, very basic formula for the volume. Volume is always the integral of the area, right? Integral of the area. Maybe it's with respect to x, maybe it's with respect to y, maybe it's with respect to h, as it will be in this case, but it's always the integral of the area because you're adding up all of those little bitty disks, okay? And we know that each cross-section is a circle, so our area will be pi r squared, and we know what r is. So I'm going to write that down. Volume is the integral from a to b. H starts at 0 and ends at 10. And the area is pi r squared, and here is r. And we square it. That's pi r squared dh. Okay? And there's the integral. I'm pretty sure I got a point just for getting that integral. And then we're going to actually evaluate the integral. So the pi here, I'm going to bring out. Okay? And then I'm going to have 1 over 20 squared times this squared, right? The 1 over 20 squared I'm also going to bring out because that's just another constant. So I'm going to bring out the 1 over pi, and I'm going to bring out the 1 over 20 squared, which is 400, like that. Then I'll have the integral from 0 to 10, and now I just need to square this little binomial. That will be 9 plus 6h squared plus h to the 4th dh. That makes it super easy to integrate. So we have 1 over 400 pi times, so here's the antiderivative, 9h plus, this will be h cubed divided by 3, so 2h cubed plus 1/5 h to the 5th. Evaluated from 0 to 10. When we put 10 in for h, we'll have 90 plus 2 times 10 cubed, which will be 2,000, plus 1/5 times 10 to the 5th. And then we will, that's when we put 10 in. When we put 0 in for h, everything has a 0, so that's just 0. So this would be our safe stop spot, and that's where I would stop. They gave 1 point for the integral, just like I expected, and then 1 point for the antiderivative, and 1 point for the answer. Okay, let's take a look at part C. In part C, it says, the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3, the radius of the surface of the liquid is decreasing. The radius is decreasing at a rate of 1/5. They're telling me there dr dt at h equals 3, when the height is 3, is equal to negative 1/5. The units will be inches per second, or inch per second. Okay? At that instant, what is the rate of change of the height with respect to time? So we're asked to find dh dt at that instant when h is 3. So they're asking us, this is a little related rates problem. Okay? So I'm going to grab my equation for r that they gave me. Here's the equation for r. And I'm going to take the derivative of both sides with respect to t. Derivative of both sides with respect to t. So derivative both sides with respect to t. Okay? On the left-hand side, I will have dr dt. And on the right-hand side, I'm taking the derivative, right? So if I distribute this 120 through the parentheses, I'm going to have this constant. The derivative of the constant is just 0. And then I'm going to have 1/20th times h squared. And the derivative of that with respect to t is going to be 2 times 1/20th, which is 1/10th, h to the 1st, times dh dt. Don't forget implicit differentiation there. Okay? Now we're going to plug in the values that we know. Okay? So when h equals 3, dr dt is negative 1/5. H is 3. So all we have to do is solve this for dh dt. So this will be 3/10, so I'm going to multiply both sides by 10 over 3. So we get dh dt is negative 10/5, or negative 10/15, or negative 2/3. Okay, They did not ask me to write units for it, so we're good. Let's see how they scored this one. They gave 2 points for what they call the chain rule, 1 point for the answer. The 2 points that they're talking about are applying the chain rule right here and writing dH/dt and dR/dt. So that implicit differentiation. So 3 points total. So this one was for 3, 3, and 3. Okay, next up, I would like to do the BC problem from 2007 with you. The BC problem from 2007. In this packet is also the AB problem from 2007, and that's another nice problem to do. I'll leave that one for you to do. Okay, so let's take a look at this. It says let f be the function defined for x is greater than 0. We'll have to keep that in mind. That might be important. With f of e is 2. F of e is 2. So there's a little initial condition. And f prime, the first derivative of f, is given by this. So they're giving us f prime. So what I see when I even before I look at the questions, I see they gave me a derivative and they gave me an initial condition. So I know if they ask me to find any other value of f, I can set up the first fundamental theorem and find any other value of f. Okay? This is no calculator here. All right, part A. Write an equation for the line tangent to the graph of f at the point E2. At the point E2. So line tangent, and the equation of any line, we need a point and a slope. They gave us the point. The point is E2. To get the slope, we need f prime at E, right? F prime at E. They gave me the equation for f prime. So f prime of e will be e squared ln of e. Natural log of e is 1, so this is just e squared. So the equation for the line tangent at E2 will be y minus the y value is equal to the slope times x minus the x value. And that is it. Okay, the way they scored this one, they gave 1 point for finding f prime of e and 1 point for the equation of the tangent line. So 2 points for that one. Okay, part B. Is the graph of f concave down or concave up on this interval? Okay, concave down or concave up. So to find concavity, we need to find f double prime. So they gave me f prime. And we can take the derivative of f prime to get f double prime. So the derivative of this, we need to use the product rule. I'm going to start with the x squared. The derivative of x squared is 2x. Multiply that by ln x plus. Now I'm going to leave x squared alone and multiply by the derivative of ln x, which is 1 over x. And since we're determining concavity, I'm going to, I need to see if what values of x make this 0. Since we only want it from 1 to 3, maybe there's a change in there. Let's see what this is. I'm going to simplify this. This is 2x ln x plus x, right? And I can factor out an x, and I have 2 ln x plus 1, right? So I know just from looking at this, I know that in this interval, ln of 1 is 0. ln of anything bigger than 1 is positive. So right here, if x is bigger than 1, this is going to be positive. So positive on our interval. And of course, x is positive on that interval. Therefore, positive times positive is positive. So on this interval, f double prime is positive. So f is concave up on that interval, since f double prime is positive there. This was worth a total of 3 points. They gave 2 points for finding f double prime, and they gave 1 point for the answer with a reason. I think you could have done a little sign chart on that as well, and that would have worked out perfectly fine. The only values of x that make this 0 are 0, and we'd have to solve that. We'd have to solve this for ln of x is equal to -1/2. That would be e to the -1/2, right? So we do a sign chart on that. It might be a little bit confusing, but it definitely would work, especially because you're only looking here, okay? All right, part C. Use antidifferentiation to find f of x. Well, f prime of x, they give us, is x squared ln x. So to find f of x, of course we're going to use antidifferentiation. So the integral of f prime of x with respect to x is going to equal the integral of x squared ln x with respect to x. From the left-hand side, we get f of x plus some constant, which I'll combine with the constant I get over on this side, right? And from this side, we need to find the antiderivative here. Well, here's your integral. It's very straightforward. We have x squared, which is algebraic, times natural log x, which is transcendental. We cannot use a u sub here. That's something you should always check first. Can I just use a u sub? Can't do that. So we're going to go off to the side and do by parts on this. So we're going to go off and do by parts. We have natural log and x squared, algebraic and logarithmic. We know that we should always let u be the logarithmic function if it is there. dv will be everything else, so x squared dx. Remember your light. If there's a log, let that be u. Alright. du is 1 over x dx. v, to get v, we take the integral, so v is going to be 1/3 x cubed. So over here, we're going to have, this integral will be uv, remember uv minus integral v du. So 1/3 x cubed ln x, that's uv, minus the integral of v du. When I multiply x cubed times 1 over x, I'll get x squared. The 1/3 I'm going to pull out of my integral, and so I'll have x squared in there dx. Okay? So now I have 1/3 x cubed ln x minus 1/3. The antiderivative of x squared is 1/3 x cubed plus c. Right? And that is it. Let's see. Is there a way for us to find c? Is there a way to find c? they tell us that f of e must equal 2, so I'm going to use that to find c. So now I have f of x is equal to this. But f of e is 2. So I'm going to replace x with e. I'll have 1/3 e cubed. Natural log of e is 1 minus 1/9 e cubed plus c. And that must equal 2 because f of e is 2. So c is 2. Let's go ahead and combine these, you guys. 1/3 is 3/9. 3/9 minus 1/9 is 2/9, right? So 2 minus 2/9 e cubed. So f of x will be 1/3 x cubed ln x minus 1/9 x cubed plus 2 minus 2/9 e cubed. Okay. So there's my f of x. I used it to find f of x. We're good. The way they scored this, they gave 2 points for the antiderivative. So 2 points for this step here, okay? And then they gave 1 point for uses that initial condition, and 1 point for the answer. So that guy was worth 4 points. Okay, so there were our 3 examples to do, and now it's your turn. I'd like you to do the first, let's see, there were 8 in here, so do the first 2 in your packet for tonight, and then we'll do 3 the next night. Okay? All right, good luck, and I'll see you in tutoring.